All right, welcome to the live. Let's get started and jump right into it. So today we're going to be doing two stats papers. We'll do the 2020 stats paper and the 2021. The 2020 paper is harder than the 2021 one I found. So I'm just going to do full walkthroughs, show you how to do it, show you exam techniques. So let's go right in with question 1. So Venn diagram shows the probabilities associated with 4 events, A, B, C, and D. Write down any pair of mutually exclusive events from A, B, C, and D. So mutually exclusive means not at the same time. So what you're looking for are circles that aren't overlapping. So you could pick A and C, for example. Another option you could pick is D and B, or D and C. These are all the pairs of non-overlapping circles. And it says draw any pair, so you just select one from above. This is Edexcel Salah. So you just select one. If you do put more than one, they all have to be correct, okay? So make sure you read the question carefully. Just put down one. If it says one, you don't want to risk that mark. So part B, given that the probability of B is equal to 0.4, find the value of P. So if we're looking at B, this is the circle for B. So we know that we can say that the probability of B is equal to 0.24 plus 0.07 plus, is this the standard maths? This is standard maths. This is not further maths. And then, so you add this, this, and this plus P, and we're told that's equal to 0.4. So if you just rearrange and solve, you get P is 0.09, and that's it for 1 mark. So in that, I would straight away put my probability there so I can easily refer to it throughout the question. Okay? Given also that A and B are independent, find the value of Q. So if you're told independent, there's one thing that you need to remember. For further, you don't really get 1 markers. Yeah, not a lot of the time. And the 1 markers tend to be a lot of work rather than this. All right, so if you see that two things are meant to be independent, this is the formula you do. The probability of A times the probability of B is equal to the probability of A and B. This will be on the intersection. This will be on my YouTube channel. I'll post it as soon as I can. It does take a few hours though at night. So yeah, hopefully should be up by tonight. So probability of A times PB is equal to this. So all we've got to do is substitute in. So what is the probability of A and B? So this is A, this is B. The intersection is this section here, 0.24. So equals 0.24. We need to know the probability of A multiplied by, we know PB, they've told us, is 0.4. So the probability of A is equal to 0.6 from the question. So they need me to find Q. So okay, I know that everything in this A circle, which is here, adds to give me 0.6. So that means that Q is just 0.6 subtract all of them added together, 0.24 plus 0.16. And that gives us 0.20. So that is the value of Q, which I'm going to put in as well straight away, 0.2. So hopefully this is making sense so far. I'm just going to check the comments. The rates of change question impure to your no. Yeah, my YouTube handle is the same as my TikTok one. Yep. And this is stats. Please, can you repeat that? All right, so I'll repeat part C again. So they're telling me that A and B are independent. So that means this formula is true. The probability of A times PB is P, A, and B. This is from the stats year 1. So we know we want to find the probability of A, right? We don't know what that is because Q is over there. But we know the probability of B is 0.4. The probability of A and B is this section here, the intersection of them both. So the probability of A is just 0.24 divided by 0.4, we get 0.6. So we know that this entire circle sums to give 0.6. So that's Q plus 0.24 plus 0.16. So to find Q, you just do 0.6, subtract the other values, and you get 0.2 for that. All right. This is A-level stats. How do you know PB is 0.6? PB is not 0.6, PB is 0.4 over here. The value of PA is 0.6 because of this formula. It's in the first textbook, and I think it's the probabilities chapter in the first textbook. Okay, cool. Part D is two parts. They give us further information that the probability of not B, that's the complement of B, given C is 0.64. Find the value of R and then the value of S. So the way I'm going to go about that is first write down my formula that I know associated with the given that. So that's probability of not B given C. That's equal to the probability of not B and C divided by the probability of C. And I've got a video down my list on conditional probabilities. So that they're telling me is 0.64. So this equals 0.64. Well, what's the probability of not B and C? Let's find that on the diagram. So this is C, but they don't want the B, so that's just R. So this is equal to R. And now what is the probability of C? Well, that is just 0.09 plus R. 0.09 plus R. And that is equal to 0.64, which is what they've told me. So for part 1, if I just rearrange and solve for R, I get 0.64R plus 0.0576 is equal to R. I've just multiplied this denominator by 0.64. And then if I rearrange, I get 0.0576 equals 0.36R, and therefore R is equal to 0.16. So that's part 1 solved. Now, how am I going to find the value of S? So I'm going to write 0.16 there. Well, S is the only one missing, and we know that sums to probabilities are all equal to 1. So using that rule, that the sum of all probabilities is equal to 1, S is going to be equal to 1 minus every single value we have there. So that's 1 minus 0.6 minus 0.07 minus 0.09 minus 0.16. This is the probability of A. That's just a value given. That's P and that's R. So this would be equal to 0.08. And that is how you do question 1. In my opinion, probability questions are my favorite type of questions in the stats paper just because they're not as messy. They're a bit more like puzzle-like and problem-solving skills-like. But does this make sense to everyone? I'm just going to check the comments. Hey, Keanu. Do you need the equation or can you get the marks for just writing it and expecting the Venn diagram? It depends. Let me show you what the mark scheme says for this. The mark scheme says for question 1, this is what you need to do. So you get a mark, you can see in D1 for the equation there. And okay, so you need to use independence and see both so you need to use the equations. You need to show your working to get the answer, Yusuf. This is for A-level math stats. This question is kind of GCSE related. Yeah, I see in the comments, but the last part is more A-level. All right, cool. So that's question 1. Nice start, good chunk of marks. Make sure you maximize the easy marks as much as you can. So these questions won't really get much harder. Yeah, the simultaneous equations is the hardest they can get, but on my live on Wednesday, we'll do the 2022 paper. There's a really obnoxious Venn diagram question there. Triple Venn diagrams tend to make it a bit harder. So yeah. Are you gonna do SATs 2? Is that the year 6 SATs? Or the American SATs? Oh, mechanics. Yes, I'm doing my mechanics live tomorrow. So I'm going to do the mechanics sections of these 2 papers. And then Wednesday, I'm going to do stats and mechanics. Yep, that could be the triple one with Z in it. All right, cool. Number 2, the large data set question. How do we all feel about the large data set? We don't have to learn how to no, you do need to know how to calculate the PMCC. But I think one of the questions tells us to do that I'll go through. So I'll show you guys, or I'll tell you guys how to do that. So don't worry. So you hate it. Yeah, large data set questions, leaving it till day before. I'm not gonna lie, that's what I did too. 2 marks out of 48, exactly. So most of the time, it's not too bad, but sometimes like the next paper I'm going to do gives a really obnoxious large data set question. You're going to have a geography lesson in a bit. So you're going to see why. So let's start. Ba-ba-ba. And just underline and make sure you know the places. When I did my stats, I want to tell you, when I did my stats question, I forgot to note that the question said it was in Perth, and I missed out on the last mark because I made the wrong conclusion. Because in Perth, the seasons are the other way around, remember? Because it's Australia, Southern Hemisphere. So just know the significance of places. So I'm going to underline everything important here. So a random sample of 15 days is taken from the large dataset for Perth in June and July in 1987. So, okay, I'm seeing these are summer months, but since we're in Perth, they're going to be winter months, and it's 1987, so you're thinking past. So, part A, describe the correlation. So, part A is nice and simple. The correlation is clearly negative here, so that's all you need to say. Part A, negative. And you get the mark. Part B, the variable on the x-axis is the daily mean temperature measured in degrees Celsius. So there. So we can see the temperature is increasing. Using your knowledge of the large data set, so this is the question everyone hates, suggest which variable is on the y-axis. So do you guys want to have a go in the chat and tell me what you think the y-axis variable could be? There are two potential answers. Yusuf is saying rainfall in millimeters. All right. Anyone else have any other answers they want to throw out? Rainfall. All right. So I'm seeing a couple of rainfall. Awesome. That is good. That's the one I went for. So the reason is rainfall, and I'm going to logic it through so you can know how to approach these types of questions. You got to know geography, which is annoying. So you can see as the temperature is increasing, what is happening to something here is decreasing. So the something is decreasing. So for part one, if your temperature increases, what is likely to decrease? Like you guys said, rainfall, right? So rainfall is one of the answers. For part two, is just asking you to state the units that are used in this for the variable. So rainfall is measured in millimeters. There is another alternate answer, which is a bit of a physics and geography lesson. Does anyone know it? GCSE geography knowledge, exactly. So this is what level? This is A level. Stats, wind speed. It's not wind speed. Wind speed wasn't given on the mark. It is pressure, exactly, pressure. And I'm going to tell you why. So this is a bit of a physics lesson with me. So pressure, and the unit I'm just going to write real quick is HPA, or you could say pascals, hectopascals, MB, or millibars. So the reason the pressure decreases is because the temperature is increasing, right? That means your particles are more spread out, which means that there's less particles per hitting a unit area. So your pressure is decreasing. So that's why it's pressure. It's annoying. You gotta know geography for these large data set questions. But yeah, does that part B make sense? So it's not as bad as you think. Just when you see it, don't go like, oh, this is so dumb. How am I going to do this? Logic it through. See, rainfall, pressure, think of all the other variables and go. I don't want to think about physics. Oh, dude, you got mechanics. You got physics coming up. Okay, cool. Whenever I see 5% significance level in the question, I'm in heaven. How there are exams. The stats in mechanics exam is still up on Thursday. Still got, I think that and chemistry maybe is afterwards. Physics 3 tomorrow. Is that A? That is A level, yeah. Oh, best of luck with that. Physics 3 is the synoptic one, right? That's the one where they use all the knowledge. Alright, cool. So, next one. Stav believes that there is a correlation between daily total sunshine and daily maximum relative humidity at Heathrow. So there are two different variables here, and it's a different location. He calculates the product moment correlation coefficient, so that's R, between these two variables for a random sample of 30 days, so that's N, and obtains R equals negative 0.377. Carry out a suitable test to investigate his belief at a 5% significance level. Clearly state your hypothesis and your critical value. So, is this a one-tail or a two-tailed test, guys? Reading the question. One tail? What do you think is one tail? Think about it. So I'm going to read the question again. So he believes that there is a correlation between them and it's in Heathrow. He calculates this from the two variables, okay? It is two-tailed, guys. And the reason it's two-tailed is because he just wants to see if there's a correlation or not. He doesn't want to see, oh, if there's a positive correlation or it's a negative. Well, the R value is showing it's negative, but he's not trying to see that. He just wants to see if there exists one or not, right? So I'm just going to write it here for you guys. He wants to see if there's correlation or not. So this means it is two-tailed, and that means you have to have the significance level. We need to remember to do that, otherwise, lose marks. So we need to state our hypothesis clearly. So our null hypothesis, HO, is that the PMCC for the whole population, write it like this, row, so you can clearly tell it's not a P, that is equal to 0. So we're assuming there's no correlation. Our alternate hypothesis is that there is a correlation, is not equal to 0, which means it could be positive or negative correlation. All right, does that make sense? All right, cool. So, yeah, they hate STEM students putting us all at the end. So I've stated my hypothesis clearly. Now I need to find my critical value. So my sample size is 30. So sample size equals 30. So at n equals 30, at a 2.5%, remember it's two-tailed, significance level, we need to find what R is equal to. So the critical value is equal to, and I'm going to show you how to read that off the stats and mechanics formula book. So we go here, we're going to scroll all the way down to find the correlation coefficients, and this is the one we want, product moment coefficient. So our level is a 2.5%, so we're looking down here, and we have 30. So if we read across, we get this value here, 0.3610. Does that make sense for you guys how to read this diagram off? So here, the critical value is plus minus 0.3610. So since the product moment correlation coefficient is negative, we'll take the critical value as negative 0.3610. So now we just pick that. All right. So then our critical region is R is less than negative 0.3610 because it's negative, right? You have to go more negative for that. So that is to reject HO. So what is our R value? He told us is negative 0.377. So negative 0.377, and I'm comparing it to negative 0.3610. That is more negative. Therefore, R is less than the critical value, 610. So I can say enough, therefore there's enough evidence to reject HO and suggest a correlation between, and then you need to write out the full names of the variables. So daily total sunshine, I'm just writing them shorthand, but you need to write it full, and the daily maximum humidity. So that is how you do a hypothesis test for PMCC. So it's not too bad. All you have to do is note if it's one or two tail, and then you state your hypothesis. Notice I've said it clearly with this line over there. So that's my hypothesis. And then I've done my working. Sample size is 30. So at n equals 30, at this, I've read this from the table. The PMCC is negative, so my critical value is a negative version. Again, I put the bullet point there to make it clear that that is that in the question. So I said my critical region is this to reject the null hypothesis. Well, that is less than it. So there's enough evidence to reject it, and then just state what the theory is in words. So that's what you need to do. All right, reading through. How come do you find people into the regular? So I use a significance level to find the critical region. So the significance level here is 2.5%, right? So from this table, the significance level is here, and I had a sample of 30 days, right? So I see where it's 30 and I read across there. That is my critical region. That's how you have to do these types of questions, okay? There are 3 marks and they have they come up quite often, but they're not too bad. So part D, so because we're testing for zero correlation. Yep. So on a random day at Heathrow, the daily maximum relative humidity was 97%. Comment on the number of hours of sunshine you would expect on this day and give a reason for your answer. This is an obnoxious question because it's 1 mark, but it's just so weird because they're asking you to comment on sunshine hours given humidity. So we're gonna logic this through. So R is negative 0.377, right? So we know that we've got a negative correlation because R is less than 0, right? So here the humidity would be high, and because the correlation shows that there's a let me start again. So here the humidity is quite high, right? And because we know that there's a negative correlation, there's evidence to show that, we expect the amount of sunshine hours to be lower than average for Heathrow. So the answer you would have to say is this. So you'd have to say this first, and then you say because humidity is high and because there's evidence of a correlation, we expect amount of sunshine hours to be lower than average. You get the marks for saying lower and average for Heathrow. You have to say the word average because it is quite high, right? And you could also they allow you to say like an hour. So the average number of sunshine hours, like let's say, is about like less than 5. So if you set a number less than or equal to 5 hours, you'd be good because they expect you to know apparently that the large data set mean for 2015 is 5.3. So that is less than 5. So that's how you do the last part. Again, you're just using what you've proved here to try and draw a conclusion and use geography again. So, yeah, I've heard paper 2 was not the best for you guys. They kind of duped you with the initial questions in that, right? Paper 3, though, always like just be very cautious because you don't know what they could include. Binomial and first principles. They could use binomial in the paper 3 maybe if they want you guys to do an algebraic binomial and you have to use the formula. So yeah, make sure you know how to do that. I think I'm going to run through how to use binomial formula in one of these questions coming up. Vectors. All right, cool. Question 3. Each member of a group of 27 people was timed when completing a puzzle. The time taken, X minutes, for each member of the group was recorded, and they're shown in a box and whisker plot. Question A, nice 1 marker, find the range of times. So the range is just the maximum value minus the minimum value, and you have to include outliers. So the maximum value is over here, so that is just 68. And the minimum value is over here, so that is 7, so that's minus 7. That's just 61. That's how you do that one. Part B, find the interquartile range. So the interquartile range is from here to here, remember? So IQR is Q3 minus Q1, or the upper quartile minus the lower quartile, and that is equal to 25 minus 14, which is 11. So part A and B are nice and simple, this reading off a box plot. Part C. For these 27 people, the sum of x is equal to that, and the sum of x squared is equal to that. Calculate the mean time taken to complete the puzzle. My video about the large dataset question, I go through how to calculate mean time. It's not too bad. So you have x bar is equal to the sum of x divided by n, right? It's adding all those values and dividing by how many there are. So the sum of x is given 607.5. How many n values are there? Well, they've told us 27 people have done the puzzle. That's equal to 22.5. So that's my mean. Part D. calculate the standard deviation of times taken to complete the puzzle. So it's given in the formula booklet. So the standard deviation is equal to the square root of the sum of x squared over n minus the mean squared. And it's, again, just a nice substitution. So that's the square root of, what is the sum of x squared? They've given us 17623.25. 17623.25 divided by 27 minus 22.5 squared minus the mean squared. And if I put that into my calculator, I get 12.1 to 3 significant figures. So that's how you do that. And you guys need to remember that variance, I'm just going to put this as a side note, variance is equal to sigma squared, right? So for that one, you don't do the root if they ask you to calculate the variance. So nice ABCD, nice easy marks. Taruni defines an outlier as a value which is more than 3 standard deviations, so there's 3 lots of that, above the mean, so plus mu. So I'm just going to find 3 standard deviations above the mean. So E mu plus 3 standard deviations is 22.5 plus 3 lots of 12.1, and I'm going to use a full answer in my calculator, and I get 58.8 to 3 sig figs. Now I can just go back to the question and see what they're asking me. State how many outliers Taruni would say is in this data. Give a reason for your answer. So I need to look for how many are above 58.8 minutes. So that's about there. Well, there's just one value there, which is an outlier. So I just say if above 58 minutes, 58.8 minutes, then that means it's an outlier. And therefore, only one outlier. And I just say where it is at 68 minutes, just for completeness. All right. I'm just gonna check the comments. Is this all making sense so far? IQR questions are easy marks. Hypothesis testing, don't worry. I think we have got a hypothesis testing question coming up. This is not GCSE maths, guys. This is A-level maths for the stats mechanics exam coming up. All right. Adam and Beth also completed the puzzle in A minutes and B minutes respectively, where A is greater than B. So A took longer than B. When their times are included with the other 27 people, the median time increases. However, the mean time does not change. Suggest a possible value for A and a possible value for B, and explaining how your values satisfy the above conditions. So I'm just going to write them out, what my conditions are in easier words so I can understand. So they tell me that the median increases. So if the median increases, we know that what is the median currently? The median is at 20. So if you add their times in it, A and B are both greater than 20, right? To shift the median upwards to the right. So that's one fact. If the mean is the same, well, we know that A plus B divided by 2, their mean must also be the average, 22.5, because the mean has not shifted to the left or to the right. So that means that therefore A plus B is equal to 45. So that's one thing I know. And I know that A is greater than 20 and B is also greater than 20. And if A is greater than B, I need to come up with any two values that satisfy these two conditions. So two numbers that add to give 45 that are different, 23 and 22. So A would be 23 and B would be 22. They both add to give 45. Cool. And they're both greater than 20. So that is one set of solutions. So they allow any pair of answers for this as long as they satisfy these three conditions. That's how you would work this question out. Does this make sense? Content for this question, yes. No. AS level. This question is AS level, yes. This is an AS level question. I don't understand. Okay, I'm going to go through it again, and we're going to, this time, try and visualize a number line with different times on it, okay? So, they're telling me that Adam and Beth also completed the puzzle in A and B minutes, where A is greater than B, so A took longer than B. When their times are included with the rest of the 27 people, the median time increases. So here, I'm going to use a blue. This is the median. Wow, it does not like the shift colors. So this is the median time, right? They're telling me it increases. So the median is going this way, which means that A and B have to be greater than 20. Both of them have to be greater than 20. That's the first condition I wrote over here. That's all I know from that sentence. Now let's look at the second sentence. The mean time does not change. Well, that means that where is my mean right now? My mean is calculated as 22.5. So that is about here. I know that one of the letters has to fall to the left and one has to fall to the right? So it doesn't shift this. So let's say B would be here and A would be here, right? Because A took longer than B. So we know that when we add them, well, we need to get the midpoint of them, which is the mean, 22.5, since that is not shifting. So we can say that A plus B divided by 2 is 22.5. Therefore, the mean does not move anywhere. So A plus B is 45, and we know that A and B are greater than 20. They told us in the question that A is greater than B, so we just need to come up with two numbers that satisfy these three conditions. So I said, okay, two numbers that are different that add to 45 are 23 and 22. All right, so they're both greater than 20, and A is greater than B, so that's how you do that answer there. Does that make sense? This is just one of those weird logic questions in stats that you tend to get. Awesome, glad it makes sense. So, part G. Without carrying any further calculations, explain why the standard deviation of all 29 times will be lower than your answer to part D. Well, for this one, you just need to say that both values of the time, 23 and 22, are less than one standard deviation from the mean, and this is the main bit. So the standard deviation of all 29 values is smaller. So you're putting two smaller standard deviations. That's going to shift all the standard deviations of all values down and make that all smaller. So that's how you would do part G. And this is, yeah, big chunky question on box plus. But yeah, that's how it goes. Hopefully that makes sense. I'm just going to let you guys have a quick read of question box plus. But yeah, that's how it goes. Hopefully that makes sense. I'm just going to let you guys have a quick read of question 4 now. So nice probability distribution question. So we're now thinking year one probabilities. The discrete random variable D has a following probability distribution. So the D can take these values, 10, 20, 30, 40, and these are the probabilities I get each value. Part A, show that the value of K is that thing there. Well, there's only one other bit of information I have, and that as soon as I see this, I need to think all probabilities add to equal 1. This is not GCSE further maths, this is A-level statistics. So all probabilities add to equal 1. So if I add all of these, I'm going to factorize out the k, so I'm not writing that too many times. It's 1/10 plus 1/20th plus 1, if it lets me write it, 1/30th plus 1/40 plus 1/50. That is going to be equal to 1. So if I just add all of these in my calculator, I get 137/600, which is looking nice because that's just the reciprocal. That's equal to 1. So therefore, k is equal to 600/137. Nice question there. You just need to know all probabilities add to equal 1. Now, this is where it gets a bit weirder. This is the type of questions that people don't like, which I'm going to show you how to, go about them. So the random variables D1 and D2 are independent and have the same distribution as D. So it looks identical to this. Find the probability that D1 plus D2 is equal to 80. So I'm going to write that out. The probability that D1 plus D2 equals 80. So I know the values that D can take are 10, 20, 30, 40, 50. So D1 and D2 can also take these values. So I need this probability that if I add two of these values, I get 80 only, okay? So if I have a 10, I need a 70. Well, this doesn't have a 70. If I've got a 20, I need a 60. Well, this doesn't have a 60. If I have a 30 from D1, D2 could be 50. So 30 plus 50. If I have a 40 from D1, D2 could be 40. So that's just 40 plus 40. If I have D1 is 50, D2 can be 30 plus 30. And that's it. These are how I can get equals to 80. So now all I have to do is just my probability. So if you have two things going on, you multiply and you add each of the separate ones. So the probability of D1 plus D2 equaling 80 is 30, the probability of 30, which is k over 30 times by k over 50 plus k over 40 times by k over 40 plus k over 50 times k over 30. And if I multiply that out, I get k squared multiplied by 47 over 24,000 in my calculator, just multiplying and adding through. And then I know my value of k is 600 over 137. So if I just sub in, I get 0.03756 and so on, which is equal to 0.0376 to three significant figures, because that's what the question wanted me to do. So that's how you do this sort of question. So I'm going to repeat that again. So we just need to understand the notation. That's probably the hardest part. So the probability that D1 plus D2 is equal to 80. So imagine this is the distribution for D1. And it's also the distribution for D2 because it's telling us it's the same, right? D1 can take any of these values and so can D2. So if I select a value from here for D1 and I select another value from there, what is the chance that both of those, when you added, equals 80? So let's say I selected 10 from here. I need 70 from D2. Well, that doesn't exist. If I select 20 for D1, I need a 60 for D2. That doesn't exist. If I select 30 for D1, if I have a 50 from D2, I add those, I get 80. So that is one possible way of getting 80. Let's do it another way. 40 from D1 and 40 from D2 give me 80 as well. And 50 from D1 and 30 from D2 will also give me 80. Just know that they are the same distributions, okay? So that's how you do that. So then you just have to take the probability of these happening and adding them together. So if I have 30 from here and 50 from D2, you have to multiply them, right? Because it's an and, so you have to multiply like here. And then you add that with the other combinations there. Then if you just multiply that out, expand it, and multiply by k squared, you get this as your answer. So that is how you do that. And let me just check the comments. Hopefully that makes sense now again. I'm late, bro. How'd you do A? So for part A, you just need to remember this fact over here. All probabilities add to equal 1. So this plus this plus this plus this plus this, all of it equals 1, like I did here. I just factorized out the k to reduce my writing. And then you can just rearrange for k. Right? This is A-level stats. I've never seen these types of DRV questions. I still don't get it. Okay. Let me just think, how else could I explain this differently? Okay, so you see this thing up here, this distribution up here. Erase that. So this table is my distribution, right? This table can be called D1 as well, and it can also be called D2. This is a probability distribution, but it's one of the weird questions that doesn't really fall into anything we learn. It's just a problem solving one. So I need to find when this D1 and D2 add to equal 80. So I can select values from here and value for D1 and the same values because D2 has the same distribution, and I need to make them equal to 80. So if I select 10 for D1, I need a 70 from D2. Well, D2 doesn't have a 70, so that doesn't work. If I get a 20 for D1, I need a 60 for D2. Well, I don't have that, so that doesn't work. If I select D1 as 30, I need D2 as 50. Well, D2 as 50 exists over there, right? So if I do 30 plus 50, I get 80. So that's one way of getting D1 plus D2 equals 80. Then I could do D1 and D2 as 40 to get that, and D1 as 50 and D2 as 30, because remember, different ways around is also different methods. So the probability of D1 plus D2 equaling 80 are all of these different ways over here. So if I just multiply the probabilities and add them together, the probability of 30 plus and 50, so is k over 30 times k over 50, because remember, it's like you're going across the branches, you multiply across for successive probabilities. You add it with another different possibility, which is 40 and 40, like there, and then you add that with another possibility. Then you just do your algebra, substitute in, and you get that. So it's just different ways of knowing how to get the values. These questions, there's no really set way of teaching them or revising for them. You just gotta take a breath in the exam, see how to logic it through. So that is that. The next one gets a bit weirder, guys. It's 5 marks. And this is what I have. How do you get k squared? Well, you can see k times k, k squared. You have a bunch of those. So I just factorize that out. All right, cool. So the next one, apparently you guys didn't get any geometric sequences questions or series questions in your paper two. So who knows? Any topics that didn't come up in your paper two could be assessed kind of like this one. All right, so we're gonna walk through this and see how it goes. And it gets a bit weird, but stay with me. A single observation of D is made. The value obtained, well, D, is the common difference of an arithmetic sequence. The first four terms of this arithmetic sequence are angles measured in degrees of a quadrilateral cube. So quadrilateral, that means you got four sides. Find the exact probability that the smallest angle of Q is more than 50 degrees Celsius. It seems so weird, this question, reading it. And you're like, probably, if you are confused, you're like, what do I even do? How am I going to show the smallest angle is less than 50? Remember, like I said, take a breath, put what you know, okay? Because you know a lot about arithmetic sequences. So they're telling me it's an arithmetic sequence. So I'm going to write that out, arithmetic sequence. And I'm going to go through this question kind of slowly just so we can understand. Chances of getting a quartic graph and finding range of k values, kind of slim for a stats and mechanics question, but it could be in like a variable acceleration kind of question. All right, so I'm just going to go through this, then I'll look at my comments at the end, all right? So we know what an arithmetic sequence looks like, right? Your first term is a, your next term is a plus d, your next one is a plus 2d, and your fourth term is a plus 3d. So they tell us we've got four terms, okay? So all of these first four terms are my angles because they told me in the question that the first four terms of this arithmetic sequence are all angles measured in degrees of a quadrilateral. Well, if we have a quadrilateral, we know that the sum of the angles is equal to 360 degrees. So we could just say that the sum of the first four terms is a plus d plus a plus 2d plus a plus 3d, and we get that 4a plus 6d is equal to 360. Because I got 4 a's there, and 1 plus 2 plus 3 is 6. That is equal to 360. Why? Because these are all my angles. So if I just simplify through by dividing through by 2, I get 2a plus 3d is 180. And now I'm going to go back to the question. So this is all I know. Now I'm going to see, what can I do next? Find the exact probability that the smallest angle of Q is more than 50 degrees. What is my smallest angle of Q in the sequence? A. So we want A to be greater than 50 degrees. So looking at this, we have 2a plus 3d equals 180. If I just rearrange that, I get that 2a equals 180 minus 3d. I know D can take set values. So now I'm going to look back at D. What values can D take? It could be 10, 20, 30, 40, or 50. So I'm going to sub in those D values and see what I get for A, okay? So if D is equal to 10, 2A is equal to 180 minus 30, so that is equal to 150, therefore A is equal to 75. Is that value greater than 50? It is, because 75 is greater than 50. Now, what's my next value D can take? D could be 20. So 2A is equal to 180 minus 60. So A would be 120 divided by 2 as 60. 60 is greater than 50. Awesome, that is another possibility for D. Now let's say that D is equal to 30. 2A is equal to 180 minus 90. So that is 90 divided by 2, so A is equal to 45. 45 is not bigger than 50. So that is why we cannot continue. So we're going to stop. The only values D can take are these. So how do I get the probability that A is greater than 50? Well, it's the probability that D is equal to 10 and the probability that D is equal to 20. So the probability that the smallest angle is greater than 50 degrees is just when you have D equaling 10 or when you have D equaling 20. So the probability that D equals 10 is K over 10 because that's from the table up here. I'm just going to show you just so there, and 20. So I'm just going to add those probabilities together and multiply through by k. So that's plus k over 20, which is equal to 3 over 20 times by k, which is 600 over 137. And I get my exact answer they wanted, 90 over 137 as my answer. I'm going to show the full question on the screen right there, so you can see how I've logically walked it through. I'm now going to check the comments. I'm hoping my explanation made sense. So, this is for A levels. You could have a trig sequences come up in probabilities, God knows. Yeah, mech is, I love mech. This is not GCSE, do not worry. Stats is hard. Stats can be hard because it's unpredictable. What subtopics? This question, so if I were to put this in a subtopic, is I would look at the year 1 textbook, and it is, let me just find where it is, chapter 6, statistical distributions. They don't really have a bunch of questions like this on the internet and in the textbook. It's just one of those things that they love to do because it's just probabilities. Why is there pure in stats? Expect that. In the 2023 paper, I think they had an integration question as the last one with a frequency polygon. So you never know what to get. And there are questions similar to this. It is, you just have to go through all the papers and find them, because when I was revising for this too, I couldn't find many questions that were similar to this. You just gotta pray this doesn't come up. Why can't you do the formula for sum over arithmetic sequences? So you could, but then you could do that for this bit here, but then you still have, this as your final answer once you rearranged everything, right? Because you know that the sum is going to be equal to 180, n would be equal to 4, and then you just sub in your values. You're still going to have an equation that gets you down to this. So you could do it both ways. You could add them manually, or you could do the sum. They both give you the same thing. Is this paper all you've gone through? Yeah, this is all I've gone through so far. I'm going to do the 2022 paper afterwards. Sorry, 2021 paper afterwards. Makes sense? You can do the sum of arithmetic. So I'm just going to put here, can do the sum of n equals n over 2 2a plus n minus 1 d. You can substitute in. So it'll be like 360 equals 4 over 2 and so on. But then eventually you will get to this stage over here. Could you show us the question again, bro? I forgot it. All right, so I'm going to walk through this again, and I'm going to go at a slightly faster pace. So we know, just write what you know straight away. Arithmetic sequence is a plus d, a plus 2d, a plus 3d. We're told there are 4 terms, and they're all angles. And they're angles of what shape? A quadrilateral. So we know that the sum of the angles is equal to 360. So if we add this, and this, we get this equation here. You can alternatively use the sum up to n terms of an arithmetic series equation, where you just have 360 equals 4 over 2 times 2a plus 3d. And when you rearrange, you notice there's a 3d and 2a over there. You get 180. All right, so now that's where all the stuff I know, like my normal knowledge, is there. Now I need to see what does the question say. The question wants a, which is the smallest angle here, to be greater than 50 degrees. So I'm going to see, okay, the ways I can get a are 2a equals 180 minus 3d. I know different values for d. D can only take 5 different values shown in this distribution above, 10, 20, 30, 40, 50. So I'm going to just start subbing in and see what I get for a. So if d is 10, I get a is 75. That's greater than 50, so cool, that works. If I sub in d is 20, I get a is 60. Okay, cool, that still works because 60 is greater than 50. If I put d is 30 though, I get a is 45. That does not work, and any bigger values of d would make a smaller. So I'm going to stop right there. So the probability that a is greater than 50, well, when does that occur? That occurs when d is equal to 10 or d is equal to 20. So what is the probability that d is equal to 10? That's k over 10 from the table. And the probability that d is 20, that's k over 20. That is going to be equal to 3 over 20 times by 600 over 137, because that is k, and you just do a normal addition of fractions, and then you get your exact answer, because that's what they wanted, of 90 over 137. So this, yeah, awesome. I'm glad it makes sense. This is a probability distribution question, but it doesn't really fall under like a set subtopic. I hated these types of questions when revising for the exams, but you just gotta look through and find weird questions that look like this and do them. So I would recommend having a go at this question yourself, like maybe tomorrow or day after, and try and remember put down what you know. I'm going to show you what the mark scheme for this looks like, actually, so you can see where the marks come from. So here, you get 3 marks for saying what you know. You know the angles are these, and when you add them, you get 360, and then if you write your equation, you get this. This, you get 3 out of the 5 marks, which is pretty decent chunk. Then this is where you got to use a bit of problem solving skills. The smallest angle is A. We need that to be 50. So consider the cases. Always consider cases is my advice. So if D is 10, you have that, and so on. And then you just add that and that to get that. So you get quite a good chunk of marks for putting what you know. Always put down anything you know just to get the marks. Oh, physics tomorrow. Yeah, I've heard physics paper 3. Best of luck with that, guys. All right, this is the last question in this paper, and then I'm going to move on and do the 2021 paper afterwards, which is significantly easier than this. This paper took me a while to get through. So this is also kind of an obnoxious question at the very end, 5 markers down there. And just check. All right, cool. So, a health center claims that the time a doctor spends with a patient can be modeled by a normal distribution with a mean of 10 minutes and a standard deviation of 4 minutes. Using this model, find the probability that the time spent with a randomly selected patient is more than 15 minutes. Okay, this is a nice start. So part A, it is just 1 mark. So I'm going to say that X is going to be normally distributed, and these are my parameters. So that means that X is going to be normally distributed. What is my mean? 10. And what is my standard deviation? 4 squared. So that's how you put in the variance, right? So I need the probability that X is greater than 15 minutes, more than 15. And remember, with normal distributions, you don't need to do greater than or less than, because it is a cumulative distribution, not discrete. So if I put that into my calculator, what you do is you go on your calculator, click menu, then you click 7 for distributions. You have to find normal CD, which is number 2 on the white calculator. Your lower limit is 15, and your upper limit is like 9999999, and so on. Your sigma value is 4, and your mu value is 10, and then you get a probability of 0.1056 to 4 dp. I like to put my answers to 4 dp. So that's how you do part A. That's just 1 mark. Awesome. Move on. Some patients complain that the mean time the doctor spends is more than 10 minutes. The receptionist takes a random sample of 20 patients, so that's N, and finds that the mean time the doctor spends is 11.5 minutes. State your hypothesis clearly and use a 5% significance level to test whether or not there is evidence to support the patient's complaint. So, with this type of question, it's a hypothesis testing question. It is a one-tailed test. Let me just check. You know how SD is squared? Would you square it if it was variance? SD squared is the variance. So yeah, if you want to find the variance, you just square the standard deviation. So the variance, for reference, is just 16, but the standard deviation is 4. We write it as 4 squared. Standard deviation squared. So, hypothesis testing. My null hypothesis is that there's no change in the mean, right? So mean is equal to 10 still. However, my alternate hypothesis, these patients are complaining that it's taking longer than 10 minutes. So mean is going to be greater than 10. It's a one-tailed test. So I know that if X is going to be normally distributed with 10 and 4 squared, I need to use the sample mean when hypothesis testing for a normal distribution, right? So, oh, great, it rubbed out. Okay, I'm going to quickly rewrite it. Probability that X is greater than 15 equals 0.1056. Part A. Part B, HO, the mean is equal to 10. It's a one-tailed test. They're taking longer. Mean is greater than 10. If X is going to be normally distributed, we have 10 and 4 squared. So we know that X bar is going to be normally distributed. And the parameters here, the mean stays the same, but the variance is divided by N. So if I just sub in now, therefore my sample distribution of the means is going to be normally distributed. The mean is still that because we're assuming that HO is true. And then we have sigma squared, which is 4 squared. What is my N value? That's my sample size, 20 patients. So this would be divided by 20. And then on the side, I just like to put that sigma squared is equal to 0.8, which is 16 out of 20. So sigma is equal to 2 root 5 over 5. Just so I know what to put in my calculator, I write that on the side. So now that I've got all my parameters set up, I need the probability that the mean x value, which is a mean time, is greater than, why? Because it's a one-tail test and we're testing the upper tail. What is that greater than? 11.5 minutes. That's what they've observed. 11.5. In my calculator, I put the lower as 11.5, upper as basically infinity. For my sigma, I plug in this value. So I would put it exactly like this in the calculator with brackets, because that's how it's like sideways, right? When you input that, and mu is 10. So you get 0.04676 and so on, which is equal to 0.0468 to 4 decimal places. So now that's my value. My significance level, let's see what they've told me. They've told me it is 5%. So I just need to compare this with my significance level. 0.05, 0.0468 is less than 0.05. Therefore, there's enough evidence to reject the null hypothesis and enough evidence to suggest that the mean times have increased, or you could say to support the patient's claim. Patient's claim. So that's how you would hypothesis test for a normal distribution. It's not too bad. All you have to do is remember you're doing the mean distribution. When do you reject and when do you accept? So you reject, if I can write, HO, if the probability is less than the significance level. Because that's basically telling you the chance of it happening is not due to random chance. So if it's less than the significance level, you reject. You accept HO if the probability is greater than the significance level. So it's like, oh, it's just a random chance of that happening. It's more random, right? Or if it falls into the critical region, if you're doing a critical values version of that. But for this one, we can just nicely do this for our hypothesis test. I don't get it. So I'm going to re-explain how to do hypothesis testing for normal distribution. And then I'd recommend going to your textbook and having a practice of these questions because it's a bit different. So some patients complain the mean time is more than 10 minutes. Random sample of 20 patients. She finds the mean time is 11.5 minutes. Use 5% significance level. Test this complaint. So my null hypothesis is that, okay, the mean time is still going to be 10 minutes. My alternative hypothesis is that it takes longer than 10 minutes, so it's greater than 10. So I know that if x is normally distributed with these parameters, the sample mean, we have to do this for a normal distribution. This is something called, it was in further stats. My mind's just going blank now. It'll come back to me. So the sample mean is going to be normally distributed with mean is the same, but you divide your variance by n. It is bound to come up. Normal distribution is always going to come up, and it's going to be one of the longer questions, I hate to tell you. So all I've got to do is plug in my values into this distribution now. Central limit theorem. Thank you, Callum. Yeah, so this is part of central limit theorem in further stats. So x bar is normally distributed with a mean of 10, and I've got 4 squared, which is as before, and I'm just dividing that by 20. So I know that sigma squared is 0.8. That is equal to 0.8. So sigma is going to be equal to the square root of that, which is 2 root 5 over 5. I'm writing this on the side just so I know what's easy to put into my calculator when it comes to it. So now, like I do with a normal hypothesis test, I find the probability that x is greater than, and why am I taking 11.5? That is how much they've observed it to be. So that is greater than 11.5. I put the values into my calculator and I get 0.04676, so on, which is that to 4 dp. So the values I put into my calculator, the lower bound is 11.5, upper bound is basically infinite, so 99999. My sigma, I put this in exactly like this, and my mu is just 10. Now I compare it to the significance level, which is 0.05. The chance of this happening is less than 5%, which means that if it's lower, you reject the HO. If it's low, reject the HO. I'm not saying the explicit version. So therefore, there's enough evidence to suggest that the mean times have increased or support the patient's claim. If the probability was below the significance level, it's so low, there's no way that the mean is the same. Don't say it's no way that the mean is the same. You know that the mean has increased, right? Because you've done a one-tailed test. If it was two-tailed, you say the mean is not the same, or the mean has changed, rather. But this one, you can just say the mean has increased. So that's how you do that one. So I'm going to move on to part C, because part D is where it gets weird, and we're going to probably spend a bit of time on that one. So part C is not too bad. So the health center also claims that the time a dentist spends with patients, T minutes, can be modeled using a normal distribution here. Using this, find the probability that a routine appointment with the dentist takes less than 2 minutes. Okay, so that's again a nice one marker just using the probabilities. So for C, I'm just going to say the probability that T is less than 2. I just put in the values into my calculator. The lower bound would be negative 999 and so on. The upper would be 2. That would be 3.5, and my mu would be 5 from the question, because T is going to be normally distributed 5 and 3.5 squared for reference. You put that in the calculator, you get 0.1957 to 4 dp. Nice one marker again is basically what you did in part A. Alright, cool. Oh, I love when it goes away. I'm just gonna write the answer. Ci probability that T is less than 2 is equal to 0.1957 to 4 dp. Alright, so we should all know how to do a normal distribution on probability in our calculator. So now part 2, find the probability that T is less than 2 given T is greater than 0. My advice, whenever you do a normal distribution question, is draw out your bell curve. So I'm just going to write the question first. So P, that T is less than 2, given that the time is greater than 0, is equal to. So now draw it out to help you visualize what is happening here. So this is my bell curve, a beautiful drawing. I know that the mean value, they've told me in the distribution, is 5. I'm just going to write up here. T is normally distributed 5 and 3.5 squared. So 2 would be about here, and 0, let's say, is about here. I don't know why that's an arrow. So 0 is there and 2 is there. I need the probability that T is less than 2 given is greater than 0. So I need this probability here. So this is equal to, and I can just put in my bounds, and I get 0.1290. The upper bound is 2, the lower bound is 0. 1 second, it's just trying to get me to verify that the live is still running by proving I'm not a robot. Sorry. All right, cool. So you can use, and you can also use the formula. So I did it both ways when I was figuring this out. You can use one to check. So if you use the formula, that is equal to P, 0 is less than T, which is less than 2, because you want the intersection of this, right? That is the intersection. And that's divided by what? P is of T is greater than 0. So then you just get 0.1191, so on, divided by 0.9234, and so on, and you get the same answer, 0.1290 to 4 dp. So you can use both methods, but always draw it to visualize. It really helps out, all right? So now, part 3, hence explain why this normal distribution may not be a good model for T. While looking at this and our diagram we've drawn, T can be less than 0, which is impossible, obviously, because time can never be negative. So you just say, for part 3, a significant portion is like, the word they use in the mark scheme is non-negligible, which means that it cannot be ignored. So this is a significant portion of T values is less than 0, which is impossible. So you just have to say that. It's impossible to have T values less than 0. Part D. This is the weird question of annoying 5 markers at the end of this already annoying paper. So, the dentist believes she cannot complete a routine appointment in less than 2 minutes. She suggests that the health center use a refined model only including values of T greater than 2. Find the median time for a routine appointment using this new model, giving your answer correct to 1 decimal place. So there I write 1 dp. I need the median. That's also the same as the new mean, right? So what do? I'm going to draw my normal curve again to just help visualize what is happening. So we want we want to disregard, ignore, T is less than 2 in this, and find the new median. So if I draw out my curve like that, oh, that is horrible. Okay, and then like, there we go. There's my normal curve. And I know that my mean is still going to be 5 from before, and I know that 2 is about there. I want to ignore all of these. So my new median, let's just say that this is my new median value, right? Because I'm going to be shifting upwards. The new median is like the mean, right? So I know that this probability here is equal to this probability. This is P, and this is also P. Why are they both P? Well, because this is the median value. You need the same probability on either side if we're ignoring this bit here. This is A-level maths, KG1. So I want to ignore this. Well, I don't know what that probability is. So I want to make all the times lie here. The median is now greater than 5. The probability each side of the median is P because it's a median value, right? So I need to find what's the probability that T is less than 2. Well, I know the probability that T is less than 2 from this question up here. Just done my GCSE, good luck to doing A-level. Alright, so this would be 0.1957 from the working. Always use the working because sometimes the previous parts of the question will help you with later parts. And I'm going to use the full answer there. So I know that P plus this value is going to be equal to 1, right? Because all probabilities sum to 1. So from 1957 ... equals 1. So if I just rearrange, I will subtract 0.1957 and divide through by 2. I get that P is equal to 1 minus that, and divide by 2. I get that P is equal to 0.4021 and so on. So that is my P value here and here. Have I solved the question yet? Not entirely. I need to find what M is. Well, now I can just use the inverse normal, right? I've got the areas, I need M. So the probability that T is greater than M is going to be equal to, on this side, P, right? 0.4021. So using the inverse normal, the M value is going to be equal to 5.86 and so on. And it's going to be equal to, how many decimal places did they want? They said they wanted 1 dp. So that is just equal to 5.921 decimal place. Because the area here, and when you input this in your calculator, by the way, the area would be equal to 1 minus this value here, 0.4021, because it's always less than, that's what it finds. So this is how you would do this question. It's not dramatically a lot of working for 5 marks, but it's a very technical, involved question. It's a question where if you can't do it, unless you really need to think about what is happening in this and logic it through. This is the method that when I was doing it the first time for my exams revising this is the method I found easiest to do. However, the mark scheme says another method over here, which I'm just going to show you, which is a bit of a weirder method. So they're saying that requires such that P is greater than T and is given that is 0.5, and then they do ratios of them and solve for P greater than T, which implies these equations, and then they draw it out. This explanation was just too fiddly and like, it's not, logical or like beautifully laid out as kind of the method we did down here was, because this one, it makes sense what's happening, right? You have your distribution here. We want to disregard these values and find a new median up here. Well, I know that all probabilities add to 1, and then I can just use the values with the inverse normal to find what that section is from the textbook. I'm going to do this paper tonight, see if I'm time. How did you notice for the last question to do this? So for the last question to do this, draw it out. That's how I kind of visualized it, right? So I knew I did not want this section here. And if I don't have this section, well, the median is going to increase from 5 to a higher value, right? Because remember, mean, median, mode is all the same on a normal distribution. So it's going to be higher. So I know it's a median. This bit here, if I'm ignoring this bit, and this bit here have got to be the same. And then I kind of just use what you already know about normal probabilities and then add it on. So yeah, the question real quick is up here if you want to screenshot that. All right, so that is the end of the 2020 paper. I'm going to do the 2021 now. I'm just going to have a little few seconds break. What values did you input into the inverse normal? I put going down. I'm just going to put them in again to make sure I'm telling you the right thing. Hold on, give me a second. So 3 inverse normal. There is 1 minus 0.4021. That is 4. That's 3.5, and that's 5, and you get 5. So in this is what I input. The area is 0.5979, which is 1 minus this value, right? Because you're going this section. So you want P, right? So it's 1 minus that. And then you put sigma is 3.5 and mu is 5 as in the question, and then you get your answer of 5.9. I got 70% of this paper. How many of them? What grade would that be? 70%. I'd say it's about like 8 A-star, which is pretty good. But obviously combined with the other papers could like throw it. Who knows? You never know. All right, cool. So that is the end of this paper. We're gonna do the 2021 paper as well, just the stats section. And tomorrow I'm gonna be doing the mechanics sections of the same, both of these papers. So I'm gonna just put starting soon on this one. Starting soon. I'm just gonna have a few second break. All right, so the good news about this question paper is it is significantly easier than the first paper we did, so it's going to be not as intense, which is good. So, question 1A. State one disadvantage of using quota sampling compared with simple random sampling. Well, the main advantage of simple random sampling is that it's random, but quota sampling is non-random. Remember, this is one of our non-random samples. So that's the disadvantage. It's not random, which means that it could introduce bias. That's the easiest one to remember. It's not random, so there'll be bias. Question B. In a university, 8% of students are members of the dance club. A random sample of 36 students is taken from the university. The random variable x represents the number of these students who are members of the dance club. Using a suitable model for x, find this. So it doesn't tell us what model to use, but there are only two possibilities with this. Either they're a member of the dance club or they're not, so it's going to be a binomial because there are two outcomes. Bi means two, so that's how it works. So x is going to be binomially distributed. I'm going to write out my model. My n value is what? 36 students at random, and the chance is 0.08, 8%, right? So part one, the probability that x is equal to 4. So you can input into your calculator using binomial PD, and I have the second latest TikTok I posted was that. Why are you doing stats lesson now? The paper's on. This is for A-level stats. So, but I'm going to show you the method of using the binomial formula because that hasn't come up from my knowledge on the paper 2, pure paper 2. So I'm going to explain how it works just in case I ask you a weird question like that. So the way it works is, okay, how many students am I selecting from? I'm selecting from 36 students, right? And I'm doing the choose function. So it takes into account didn't write the test statistics. I didn't write it because it was given up here. So I didn't need to write it again. All right. So 36, choose. Okay, how many am I choosing from this 36? I'm choosing 4. So 36, choose 4. Okay, so now the probability of 4 successes, well, that is 0.08 to the power of 4. Multiplied by 0.08 to the power of 4. And I have 36 minus 4, which is 32 failures. So that's 1 minus 0.08 to the power of 32. That is how the binomial formula works. You have how many you're selecting from and how many you're selecting from that, 4, and this just takes into account all the different ways you had it. You have 4 successes, so that's 0.08 to the power of 4, and you've got 36 minus 4, which is 32 failures, so that's how you do it that way. If you put this all in your calculator, you get 0.1674 to 4 decimal places. So obviously you don't need to do the whole formula, I've just showed you how to use it, just so you, in case they have it completely algebraic, who knows, it could come up. You never know with that Excel. Yeah, you just have to write it. Yeah, this you don't even need to do. You can just write the answer. So yeah, you don't have to write it out to get the mark. And the teacher said you can just write it. Yeah, that's 100% correct. So for that, you just go in binomial PD and put in the values in the variable section. So part 2, the probability that x is greater than or equal to 7. If you saw my video about me trying to win the giant banana plush, you need to see that this is going to be a less than or equal to sign. So this is 1 minus the probability that x is less than or equal to 6, because that is all the values that are not greater than or equal to 7. So you get 1 minus, put this in your calculator. This I'm doing binomial CD. So 0.9777, so on. And you get 0.0222. And that's it, to 4 decimal places. So yeah, everyone's saying just put in the calculator. Yep, I was just showing you how to do it this way in case you have a completely algebraic question, so you understand how the binomial formula works. All right, cool. Next part. Only 40% of the university dance club can dance the tango. Find the probability that a student is a member of the university dance club and can dance the tango. So, see, the probability in the dance club and tango, well, you're just multiplying those two probabilities. So what's the chance they're in the dance club? 0.08. And what's the chance they can dance the tango in the club? 0.4. And you get 0.032 for 1 mark. Nice and simple. A random sample of 50 students is taken from the university. Find the probability that fewer than 3 of these students are members of the dance club and can dance the tango. This is where you have to be a bit careful. Here you've got a different distribution. So I'm going to define a different variable here. T is the number of students in the sample of 50. I'm defining my test statistic, who are in the dance club, so you'd write the full thing, and can dance the tango. So T is going to be binomially distributed. And what is my sample? 50. And what's the probability that they do both of these things? Well, I just found it here, 0.032. This is not GCSE, don't worry. All right, so I need to find the probability that less than 3 of these. So P, that T is less than 3. Well, that's the same as P is T is less than or equal to 2. And that is going to be equal to 0.7850 if I just put that straight away into my calculator to 4 decimal places. This is your sixth. That's. So this is how you do this. Remember, you need the less than equals to. And yeah, the way that like if someone is there and cannot visualize this, I'm going to show you a real quick visual. 1, 2, 3, 4. So less than 3 is these values down, right? And it can only be integer. So we need less than or equal to 2 because 2 is the maximum value you get. And this is how you would do that. Average year 8 question. Exactly. 13-year-olds should be able to do this. So that's how you do question 1. Nice simple question. I haven't seen like the part A come up like as recently, so who knows, you could get a question from unit 1 of like sampling techniques in the final. So make sure you know all the disadvantages and how to do the different types of sampling methods. All right, question 2. Question 2 is quite a nice question as well. I like the type of linear regression questions. So Mark took a random sample of 16 students from a school, and for each student recorded the number of letters of X in their last name and Y in their first name. His results are shown on the scatter diagram on the next page. So I'm going to quickly show that to you guys. There's the thing. So you got last name, first name. Sorry, other way around. Oh no, yeah, that is the way around. Okay, cool. His results are shown there. Describe the correlation between X and Y. So if I'm looking at this correlation, what sort of correlation is there, guys? I'm going to wait for someone to put it in the chat. Negative, exactly. No correlation. Well, you could guess no correlation, but in this case it wouldn't be correct because you can see like there's a general downwards trend here. It is a weak, exactly, JH. It's a weak negative correlation in this case. So you get the mark for saying just negative, and if you put the strength, you also get the mark too. So it's a weak, I'm putting that in brackets, negative. No correlation would look like if you had some values up here, down here, and like there. Like there is no line that will go through all of them. It is a horrible graph. I completely agree. Initially, I looked at this, I was like, okay, is it no correlation or is it negative? Generally, you could see it's kind of going down, so it's negative, okay? If there's no correlation, it looked not like a line, it looked like a square or a circle. So, Mark suggests that the parents with long last names, so that's X, tend to give their children shorter first names, that's Y. Using the scatter diagram, comment on his suggestion, giving a reason for your answer. Well, we can see that as the last name length increases, the first name length decreases. So technically, Mark's suggestion is viable The word they used in the exam and the mark scheme was compatible. So maybe use that if you're evaluating suggestions to do with linear data. Because why? There's a negative correlation here. And that's how you do that one. You have to give a reason, so you have to say there's a negative correlation. So, next part. The results from Mark's random sample of 16 observations are here. Use your calculator to find the PMCC between X and Y. So this you're finding R. So I'm going to tell you exactly how to do this. So in your calculator, go into menu, and then you need to go on to the statistics mode, which is 6 on this calc. So this is, you want to go onto that one over there. Then you need to go on to number 2, which is y equals a plus bx, because you've got y and x, you've got 2 different variables. And then you can just input your values. So it does take a bit of time for 1 mark. Make sure you input them very carefully. So input all your x's first and then your y's. And then you need to go into option, OPTN. So the option button is in the top left of your calculator over there. So when you click option, you need to go on to number 4, which is the linear regression one, which is regression, all right? Then you'll get told, I believe, an A value, a B value. So it should look something like, if this doesn't mess up again, because it likes to do this, it should look something like A colon B colon R colon. You read off the R colon value. So then you just get R is equal to negative 0.5446 to 4 dp. And that is the product moment correlation coefficient of this data. So I'm going to leave that on the screen for like 5 seconds if you guys want to do it and see for yourself how to get the value. But it is 1 mark which you do not want to miss, because you can see there's a hypothesis testing here which relies on that. Could you real quick do that again? Yeah, sure. So you have your calculator. Sorry if it's different. So you go into menu and you need to go into number 6, which is your statistics mode. Because you've got 2 variables, you go y equals a plus bx. So you go on 2. And then I'm going to input all my x values there. So 3 equals 6 equals 8 equals, and so on. I'm not going to do all of it now. And then my y values, I'm doing the corresponding one. So 7, 7, 4. Make sure you put them in order. So you have 7 equals 4 equals. And now I've input all of them. Imagine I've done all that. I need to find what R is, right? How am I going to do that? Always click options. Option gives you options for your calculator for this. So what do I need to find? Number 4. This is the regression topic, right? Linear regression. It's also unit 4 in the textbook, number 1, so it kind of helps. So 4. You can see I've been given A, B, and R values. Your R value is what you want to read off, and it should be equal to negative 0.5446 to 4 dp. So if you guys put that in your calculator, want to have a go for yourself before I move on, that is what you should get. Just verify you know how to do that. It's a nice 1 mark. You don't want to miss out on the exam. Easy mark to get. But yeah, hopefully that explanation made sense. And I'm going to move on to part D right now. So this one is another linear regression PMCC test. It is always going to be y equals mx plus c. Yes. Why? Because you've got 2 variables. You've got a y variable and an x variable, right? And when you put that in, you get like y equals a plus bx, right? So you got 2 different things happening. The other one is 1 variable. You've just got 1 variable to input there. You don't really want that. And you don't have 3. So yeah, y equals mx plus c. That's the one you do. That's how you do this sort of question. Take a screenshot of this section if it helps you remember the buttons to input. All right, awesome. So test whether or not there's evidence of a negative correlation. So this is telling me it's a one-tailed test between the number of letters in the last name, which is X, and the number of letters in the first name, which is Y. You should state your hypothesis clearly and use a 5% level of significance. So I'm going to state my hypothesis first. Rub that out. So part D. My null hypothesis is telling me that in the population, which is row, make sure you write your letter like this, just so they know it's not P, because you get marked down if it's a P. That is equal to 0. This is telling me that there's no correlation between this and the sample and the whole population. H1 is telling me that there's a negative correlation, so it's less than 0. So negative correlation in the population. Awesome. So now I just need to find my n value and my significance level. So what is my n value here? N equals 16. So at n equals 16 at 5% significance level, did you say we have to write down that the sign is rho? Yeah, you need to write down no, don't write down the sign is rho, write down this, like make sure it doesn't look like a P, don't do it like that, this is wrong. Make sure it's like kind of sideways and doesn't join. So make sure it's clear that it's a different letter. That's how I did in my exam. Just so it's not a P is equal to 0, because it's not P. PMC is defined by rho, not P. Exactly. Thank you, Callum. So at n equals 16, I realize on my notes I've put 10, which threw me off. At 5% significance level, the critical value equals, and now I'm going to show you how to read off the critical value from the table. So in your stats and mechanics book, you go pretty much all the way to the end there. So for question 2, your product moment correlation coefficient, what is the significance level? It is 5%. So you're going to look here, and my n is equal to 16. So it would be this value here, 0.4259. Does that make sense how you do it? P looks the exact same. How would they tell the difference? The way they tell the difference is by drawing it exactly how I did it, Jibril. So I did it side, kind of slanted. So this is how I do my P's normally, or like that. This is wrong. This is a row, so I do it kind of pigtail, and I go like that, and I don't join it. So it just looks a bit different. You can see there's a little bit of a difference between those. Make it look very different to a P. But they're not going to be overly harsh. As long as they can tell what you're doing, they're not going to be dramatically harsh. So the critical value, thank God, is saved. The critical value is going to be plus or minus 0.4259. Well, we're looking for a negative coefficient, right? So it's negative. Therefore, reject HO if R is less than minus 0.4259. What is the R value we calculated? This. And this is why it's important to make sure you get the correct R value. 0.5446 is less than negative 0.4259. Well, that is true. Therefore, there is enough evidence to reject the null hypothesis and suggest a negative correlation between, and you need to write the full thing out, the number of letters in last and first name, last name and first name. All right, best of luck with physics revision. All right, so this is how you would do the PMCC hypothesis testing for a linear regression model. And that's all you have to do. This will get you full marks in the exam if you obviously write out the full statements, but this is what I did in my exam, which got me the marks. It's nice and clear in the structure. It's telling the examiner what my n value and significance level are, because you can't just write the critical value is that and just do it, but it helps to have some sort of structure so you don't get confused and the examiner knows exactly what you're doing. So that's how you do this question. And yeah, that's the end of question 2. Not a bad question. Pretty good question. All right. Does anyone have any questions about that? I realize I said question so many times. Does anyone have any questions about that question 2? If not, I'm going to move on to question 3. And we have our good old friend Stav again, who appeared in the 2020 question paper as well, with a large dataset question. He is obsessed with this. I'm going to give you guys a geography lesson now with this question. Yeah, I'm going to give you a geography lesson towards the end, and I'm going to draw a map of the UK. So, Stav is studying the large dataset for September of 2015. So this is September, we're thinking autumn and stuff. He codes the variable daily mean pressure, X, using the formula y equals x minus 1010. The data for all 30 days from Hearn are summarized by this, and notice their y values. State the units of variable x. Well, part A is nice and simple. The daily mean pressure, what is a unit for that, guys? That is hectopascals, or you could write out the word hectopascals. Very nice. Pressure is in that. All right. Part B. Find the daily mean pressure for these 30 days. So the daily mean pressure, that's x bar. Well, they've told me y. So I could find y bar first and then uncode that. So y bar would be the sum of the y values divided by n. So that would be 214, and how many days has he taken it for? 30, which is equal to 107 over 15, just simplified. And now, with mean coding, looks like this. Y bar equals x bar minus a over b, right? You're just adding or subtracting and dividing through. So we know that the mean of the y bar is equal to the x bar, and how am I coding it? Up here, minus 1010. So all I have to do is rearrange. So x bar is equal to 107 over 15, which is y bar, plus 1010, and that gives me 1017.13 to 2 decimal places. So that's how you do that question. It's a bit of a longer one for 2 marks because you're coding and uncoding. I hope they put coding in the exam tomorrow. It could come up because I don't think I've seen it come up for a while. Who knows? But yeah, coding I think is that extra mark. So it's not bad. All right. Part C, find the standard deviation, which is mu of x of the daily mean pressure for these 30 days. So you got a bit more work to do for this one because you're just a bit more subbing in, but you get an extra mark just for uncoding it. So the standard deviation for y, which we can figure out, is, and the formula is the sum of y squared over n minus the mean of y squared, all square rooted. That is equal to, what is that? 5912 divided by n, which is 30, minus 107 over 15 squared. Notice I've used the exact answer of that. And I get 12.09 and so on. Now, the coding for the standard deviation is this. Because only scaling affects the standard deviance. Da, da, da. So the minus a does not have an effect, right? Because I would just shift everything down, right? But the how far they deviate still remains the same with that. But scaling it, like multiplying it by b or dividing by b, will change how much it deviates. So here, there's no scaling. Why? Because if I just look at the coding thing, you're just subtracting 1010. They haven't scaled the x value. So therefore, the standard deviation is not affected with this coding. Therefore, you could just say the standard deviation of x is the standard deviation of y, which is 12.09 to 2 decimal places there. All right, coding is a nice little subtopic, but yeah, that's how you do that. Now I'm going to give you guys a geography lesson for one of the weirdest large data set questions that's ever come up in my opinion. Okay, staff knows that in the UK, winds circulate clockwise direction in a region of high pressure and anti-clockwise in a region of low pressure. The table gives the daily mean pressure for 3 locations from the large data set for the 26th of September in 2015. The cardinal wind directions for these 3 locations are here in a random order. You may assume that these 3 locations are in a single region of pressure, so it's just all in one area of high pressure or in one area of low pressure. So, how am I going to do this question? Does anyone have any ideas how they want to go about starting this question in the chat? Want to let me know? I'll just jump right into it. So the way you go about doing this is you need to see if it's high pressure or a low pressure system first, right? Nah, fair enough. I don't blame you. So you're told that it's either clockwise or anti-clockwise. Why? Because they're in a single region of pressure. I need to see if it's a high pressure or a low pressure. How am I going to find out? Well, look at the pressure values. 1029, 1028, 1028. What is the average pressure? My mean pressure is, where is it? 1017, right? These are all higher than the average pressure. So I want to say the mean pressure is roughly equal to 1017, right? Hectopascals, which is what we found in the question. The standard deviation is equal to 12. So one standard deviation is 1029. So these are all high pressure. these are high pressure because they're greater than the mean plus one standard deviation, right? And they're all in one region, so they all have to be in the region of high pressure. So if you have high pressure, what did they tell me about the wind? Pressure. The wind direction, which Stav knows, is clockwise. So this would be a clockwise direction, okay? Now this is where it gets a bit weird. You need to know where the locations of these are on the thing, on the map of the UK. So you guys are going to see my beautiful artistic drawing of the map of the UK, like that. Beautiful. And then UK is with Ireland too. So I have to label where these locations are on this map. So Luchar's is up here. Heathrow is over here because that's kind of near London, right? And Herne is down here. So this is where these locations are. We know that the wind is blowing in a clockwise direction. So I'm just going to draw the wind direction in blue on this map. So clockwise is this way. That is the direction the wind is going from. We need to know the cardinal wind direction, which is basically where it hits each of these areas from. So over here, Luchar's, it is coming in, and I'm going to do it in red this time. It's coming in from this way. So it's from the west. So Luchar's is west. From Heathrow, it's coming in this way. That is from the northeast. From Herne, it's coming in this way. Well, it's the only one left as well. So it's from the east. So you have Luchar's is west, Heathrow is northeast, and Herne is east. So that is what you have to put in the table. And read the question carefully. It tells you to place each of these in the table. You have to put them in. Otherwise, you may not get the mark. East and west. So yeah, just for 2 marks, you need to figure out, okay, are they high pressure or low pressure? Well, you can clearly see they're all above the mean average, so they're high pressure. High pressure means it's clockwise. So you draw your little map of the UK there, label where they are on the map, and see which direction each of these is coming from, the wind. And then you just fill in your little table. Does that make sense? Did you guys enjoy my little geography lesson there? So, I'm gonna scroll up to questions. Guys, if I start revision now, will I be able to finish 2 years worth of content by Wednesday? Yes. Just start. Go for it. You can do it. Okay? You have to spend hours on it. It is possible. I'll be honest. I mainly revised all of stats and mechanics in the last few days between that exam, before that exam. I didn't revise it much before. Yep. Do things you don't know. Revision material. For stuff you really know. Zishan, yep, Zishan is good. What do we really need to know for the large data set? So for the large data set, if you want to sacrifice the few marks, you can, but I wouldn't recommend it because it could be the difference between you and an A star. Large data set, you need to know a couple of things. You need to know where the places are in the UK and in the world. You need to know about the different variables and their units and how to measure them. You need to know about the months that are used. Remember, it's Mo. So it's from May to October of 1987 and 2015. You can remember 1987 because it's just the numbers 987 backwards. And 2015, well, it's 2015. That's an easy year to remember, hopefully. So you need to remember the years. In 1987, I think at one point there was a great storm in one of them in the UK in a few of the months. So that could mean like rainstorm is higher. They probably won't ask you a question which you need to do that inference because it's just so niche. But yeah, fun fact right there. You need to know the differences between the UK locations and the different international locations. So you've got Jacksonville, you've got Shanghai, and you've got Perth. The main thing is Perth is in the southern hemisphere, right? It's Australia. So the seasons are switched. So their summer, well, our summer is their winter, which is a very important thing you need to remember, which I forgot in my exam. So yeah, knowing the locations, what is special about those locations, knowing which variables are what and what they're measured in, and you also need to know which ones are continuous and discrete. Also know what NA stands for, not applicable, which means that you don't have a reading for that value. TR in my large dataset video, which you can check on my page, is trace, which means it's 0.05 or less millimeters of rainfall. And the value you use in calculations is 0.0 0.025, I believe, is the midpoint of that and 0. From the top of my head, those are the main things you need to know. I wouldn't suggest knowing rough values for them because that's just unnecessary memorization. But try and infer, right? Know what each of the different variables means and how they relate to each other, right? For example, if you have a hotter day, you're likely going to have more sunshine hours and you're going to have less rainfall, right? Things like that. Just know how the variables relate to each other, and then I think you'd be all set for a large data set question. So hopefully that helps. Question 4. Nice Venn diagram question, because these are the easier marks on the paper in my opinion if they don't give you an obnoxious thing. So a large college produces 3 magazines. One is about green issues, one is about equality, and about sports. A student is selected at random for, and the events G and S are defined as follows. So G is green issues, E is equality, S is sports, blah blah blah. The Venn diagram P, Q, R, and T are probabilities. Gives the probability for each subset. So you just look at there and you see, okay, cool, you've got some missing values there. Find the proportion of students in the college who read exactly one of these magazines. So the probability of exactly one, that is in the non-overlapping sections. So that's 0.08 plus 0.36 plus 0.09. That's equal to 0.53. Easy 1 mark. Part B, no students read all 3 magazines and PG is 0.25. Part 1, find the value of P. Well, we're told that no students read all 3, so that's just 0, right? So make sure you do write it out as well officially. P equals 0, and that's it. For part 2, find the value of Q. Okay, so I know that PG is equal to, and here, this is the circle I'm focusing on, 0.08 plus 0.05 plus Q. So 0.08 plus 0.05 plus Q. They've told me that that is equal to 0.25. So Q is equal to 0.25 minus 0.13, which is 0.12. And always put that into your diagram straight away, 0.12 there. Now they've given me some more information. Given that P, the probability of S given E is 5/12, find the value of R and then find the value of T. So straight away, you want to write down the formula you know for given that. So S given E is equal to probability of S and E divided by the probability of E. That we're told is 5/12. So I need to look for the intersection of S and E. So S is there, E is there. Well, that's just R. Well, 0 plus R. So I'm just going to write 0 plus R. And what is the probability of E? That's 0.05 plus 0.09 plus R. So that is 0.05 plus 0.09 plus R. That is equal to 5/12. If I cross multiply across, I get 12R is equal to 0.7 plus 5R. 7R is equal to 0.7 and R is equal to 0.1. It makes sense because probabilities are all less than 1. You know, if you get a value greater than 1, you're wrong somewhere. So there's R. And now how am I going to find T? Well, we know that all probabilities sum to equal 1. You need to know that fact. So 1 is going to be equal to all of them added together. So that's 0.08 plus 0.05 plus 0.12 plus 0.09 plus 0.1 plus 0.36 and T, which is our unknown. So that's 1 equals 0.8 plus T, and T is equal to 0.2. So I'm going to fill that in as well down there. When you're writing this out, I would recommend to write the whole thing just so the examiner knows you're working in case you get a wrong answer in the last step when you put in your calculator, they can see you've done the correct method. All right, so one last part to this very nice question. D, determine whether or not the events S and not E and G are independent. Show you're working clearly. So we need to state that if they are independent, what is our rule? The probability of S and not E and G is equal to the probability of S and not E multiplied by the probability of G. That's the formula you should know. So we can go ahead and find them. This is equal to, no, I'm going to do this one first. S and not E. How am I going to focus on that? Well, where's my S? This is S, and not E is just this, so that's just 0.12 plus 0.36. So this is 0.12 plus 0.36. What is my probability of G? Well, they've already told me in the question. That's 0.25. 0.25. Now, the harder one to find is this one here. So I'm going to break this up. The probability of S and not E. So I'm going to go up here, change color. So the probability of S is here and not E. So I'm going to do this one over here. So I'm just going to redo. This is the probability of S and not E. And I also want the probability of G, right? So this is going to be my probability of G. I need the intersection of both. So the intersection, nicely, is just this bit over here, 0.12. Was stressing for a second, thought this was further GCSE. Nah, don't worry, this is not further GCSE. So it's just 0.12. 0.12. So I'm going to put that through and I'm going to do 0.12 equals 0.48 times by 0.25. So if I put this into my calculator, I get 0.12. So I can put a tick there. And therefore, I need to have my conclusion. Therefore, independent. Why? Because, and then I'm just going to rewrite the whole phrase at the top again, because that is my condition for independence. So I would just write this over here. And then I would get the marks right there. So this is a nice question. How long are you live for? I am live until I complete this paper. I've got 2 questions left. So I'd say about another 20 or so minutes. What's the difference between independent and mutually exclusive? So if we go into their definitions first, independent is exactly what it means in real life, right? It is one thing does not affect the other, right? So like there's no like 2 things happening at the okay, I'm going to give you both definitions first, then explain the difference. Then mutually exclusive means not occurring at the same time. So independent means that 2 things don't have an effect on each other, right? So for example, in the binomial distribution, we assume that all of the trials are independent. So for example, if you were shooting a bow and arrow at a target, you'd assume they're all independent. That means that each arrow shot is independent of each other arrow shot. You're not getting better. There's no impact on it. So there's no effect on that. Mutually exclusive means 2 things cannot happen at the same time. So if 2 things are mutually exclusive, in a Venn diagram, they would look like this as non-overlapping circles. So A and B are 2 events that cannot happen together. However, independent, they can still have an overlap. This could be independent, and we've proved this formula for independence over here, for the overlap here. So independent, there can be an overlap, and you need to remember the formula, which is over here. Well, the obnoxious version there. And mutually exclusive means it's not happening at the same time. Those 2 events are completely separate, okay? And if 2 events are independent, and yeah, use the formula. GCSEs, this is A-level, man. This is not GCSEs. Some people are still suffering. The chemistry and the math students are suffering till the end. All right, cool. So that's how you do this probability question. Hopefully that's making sense. It's a nice question. I'm going to move on to the next one, which is a normal distribution. This is guaranteed to come up in pretty much every single exam, and it is a chunky question most of the time. So the heights of females from a country are normally distributed with a mean of 166.5 and a standard deviation of 6.1. Given that 1% of the females from this country are shorter than K, find the value of K. So for this one, you need to do the inverse, right? Because you're given the area or the probability. So I'm going to first define my test statistic. So X is heights of probability. So I'm going to first define my test statistic. So X is heights of females I just buffered out for a second and my phone is on low charge. So give me 1 second. I'm just going to connect it to charge. Ba-ba-ba. And I apologize for the weird angle that my phone is at now. I'm going to try and keep it as straight as I can. There we go. Awesome. So x is going to be normally distributed with mean and sigma squared. So I know that x is normally distributed. What is my mean? They told me is 166.5, and that would be 6.1 squared. So there are two ways I could do this. I could do this by standardizing, or I could do this by using the inverse normal. I'm going to show you both, just in case you need to standardize if you have complete algebra in your exam tomorrow. So standardize. The formula, which you need to memorize, is z is equal to x minus mu over sigma. So the probability that x is less than k is equal to 0.01, which they've told us in the question. So always draw out your normal distribution to help you visualize. So you've got 0 here, and you've got 0.01. You need the z value on this. So I want to show you how to read that off on the table in the formula book. So if you scroll down, you need to find this over here. So this note, it is telling us the probability of z greater than z. So z greater than z, you would read off this value over here, right? Because that's 0.01, that's 2.363. So if I go back to the question and show you how that works, the probability that z is greater than 2.3263, this bit here is also 0.01. So because it is, you don't have to use a table, exactly. If you're standardizing, blah, blah, blah. You could also use the standard, you could also use the inverse normal, but yeah, if you're standardizing, use the table so you could read off the z value, but you could also do it using your calculator, it just helps. And you know it is symmetrical about 0, so this would just be negative 2.3263. So that is the z value. So I have negative 2.3263, my x value, which is k, that's what I want to find, minus mu, which is 166.5 over 6.1. If I multiply by 6.1 and add 166.5, I get that, therefore, k is equal to 152.3 and so on, which is equal to 152 to 3 significant figures. So this is how you would do it. If you were standardizing, you use the formula, find the z value for that probability, or you could just simply do the inverse normal method. So I'm going to show you what the steps to do. So using your calculator, go into menu, then go into 7, which is the distributions. You need number 3, which is inverse normal. Then you put the area is 0.01, and remember this is x is less than x. The sigma is 6.1 and mu is 166.5, and then you get the answer. And if you just put the answer only, you get 2 out of 2 as well. So don't worry if you decided to do an inverse normal and you're wondering where does the second mark come from. I would suggest writing this out in your exam to show that that's what you've done. So I'd write in calculator, you put that. Wait, I can't find it. I use CG50. I use this one. I think this is the previous one, is it? This is the one I use. So I'm going to show you how to use it like visually here. So go into menu, you need to find all the different things to calculate with. You need the distributions one, which on this calculator is 7. So on to 7. Then you should have a bunch of distributions, normal, binomial, and Poisson. You need to use the inverse normal. Why? Because you're trying to find a point on this. You're not trying to find a probability going backwards. You're trying to find a value that gives you a probability of 0.01. So if I click 3, the area is 0.01. My sigma is going to be 6.1, which is given to me in the question, and my mu is 166.5. And then I get 152.3 and so on, and I just rounded to 3 sig figs is 152 up there. If you write down this, like this is what you'd write in your exam, inverse normal, area equals this, and these values, then you can just put your answer as is, right? So write it to more decimal places, then round. That will give you 2 out of 2 as well if you don't do the standardized method. So that's how you would do that question. I did a bit of a long waffly explanation, but that's just both methods. If you have all algebra, you have to standardize to find mu or sigma. because you can't really put that in. Part B, nice simple question. Find the proportion of females in this country with heights between 150 and 175. Okay, that's just a simple distribution question. So 150 is x is less than 175. That's all of those values. Remember, you don't need the equals to sign because it's continuous. But then your calculator, you get sorry, that's wrong. You get 0.9149 to 4 decimal places. So in the calculator this time, you would put your lower bound as 150. You put your upper bound as 175, and you put the same mu and sigma as you have been doing the entire time here. Okay, part C. A female from this country is chosen at random from those with heights between 150 and 175. Find the probability that her height is more than 160. So in word form is kind of weird, so I'm just going to put this as a probability form with math that we're used to, right? So I need the probability that x is greater than 160 given that, why? Because we're selecting from a restricted sample space. Given that 150 is less than x, which is less than 175. Okay, we need to find the overlap between this. So what is the overlap between 160 and 150 to 175? If I just do a little number line, which might help some people, 150, 160, 170, 180, I have 160 and above, and I have 150 to 175 is going to be from 160 to 175, right? So it's the probability of 160 is less than x, which is less than 175, divided by this probability here, right? Because that's the formula we use. 150 is less than x, which is less than 175. And that is going to be equal to, and I put this in, which was into my calculator, so I just changed the lower bound, 0.7749 and so on, divided by, and it's just my same result as from before, 0.9149 and so on. Use the entire answer in this, okay? That is very, very important, because if you are rounding and you round incorrectly, you may get it wrong. So use the entire number, store it in your calculator. So the way you can do that, let me show you how to store it in case you don't know. So this is the answer I want to use, right? Just click STO, which is store, and that one, which has a little a above it, store to a. The way you use it, you go alpha, a, boom, there's a number there. This is the 2021 stats paper. I'm so confused on the first step. So the first step, I'm going to make it simple by showing you something that should look familiar. The probability of A given B is equal to the probability of A and B divided by the probability of B. Are we happy with this formula here, right? The given that formula? No worries, Tiger B. So this is the formula we use. This is telling me I need the intersection of the left-hand side and the right-hand side. So I need this event and this event to be happening at the same time. That's like how we do our inequalities diagram here. So if it is greater than 160, that is that section there. And if it's between 150 and 175, that is this section here. I need these to occur at the same time. They occur at the same time in this section here. So that is the intersection A and B. So 160 to 175 is what we put. We find our lower and upper bounds are 160, 175, put that in the calculator, you get that. This is just from over here. You divide through by that, and then you get an answer of 0.8471 to 4 decimal places. And there's no continuity correction here because we are not approximating using a binomial distribution. So the way continuity corrections work is we know that a normal distribution is continuous, right? So we can take any range of values, even decimal values in between numbers. However, if we are approximating binomially, binomial is a discrete, which is why we need to do a continuity correction and round like midway between the values, right? So we make sure we include all the values that could be rounded to the binomial values, because binomial, discrete, it's all integers. So yeah, you only do continuity corrections when approximating using a binomial approximation. So there's no continuity correction. This one we're just trying to see when do these events happen at the same time. Awesome. Gonna look at the next part. Does that make sense so far? Hopefully, everyone. So this one just is kind of taking what you know with the A given B a bit further, and you need to be able to use it in different contexts. So last part of this question, and then go one more question after this. This is the 4 marks hypothesis testing. I love hypothesis testing with normal distributions because it's not too bad. Well, I don't love it. I mean, I don't mind it. So, the heights of females from a different country are normally distributed with a standard deviation of 7.4. Mia believes that the mean height of the females from this country is less than 166.5. So this is a one-tailed and is less than the mean, right? So it's less than. Mia takes a random sample of 50, which is n. Remember, with a hypothesis testing for normal, there's always going to be a sample taken. She finds that the mean of this sample is 164.6. Carry out a test, you should state the hypothesis and use a 5% level of significance. So, step 1, state your hypothesis before defining your variable, okay? So, the null hypothesis is that the mean is not different in this new country, it's the same, 166.5. The alternate hypothesis, the mean is less than 166.5 because she believes that the heights of the females in the other country are shorter or lesser. So I'm going to define my variable y because I've used x before. Y is height of females and exactly use the words in the question given from other country. And now I can say that, therefore, which implies that y is normally distributed, and I'm going to assume HO to be true, so mu is going to be 166.5, and I've got my standard deviation of 7.4 squared, right? Because the question up here has given me a different standard deviation. Let me just check 1 second real quick before I move on, because I want to make sure I'm doing it the correct way. Give me 1 second, I apologize. Ba-ba-ba. Last part. Yep. So we have assumed HO there, so I'm just going to also just write that out here. Assume HO is true. So therefore you can use the 166.5. So y is normally distributed with these values, but I need the normal distribution of the means. So the mean of y sample distribution is 166.5, and here you're just doing sigma squared over n. So 7.4 squared, n is my sample size. What is my sample size here? They've told me is 50. So we're going to go down and divide this through by 50. And what I like to do is I like to do sigma squared over n equals 7.4 squared over 50 here, which is 1369 over 1250. And then I like to just write down what sigma over the square root of n is, because this is what you're going to put into your calculator. Square root this answer, you get 37 root 2 over 50. Do not be put off with obnoxious numbers. A-level math is like that, right? So we could just say this implies that the mean is normally distributed 166.5. That stays the same. And here is going to be 37 root 2 over 50 whole squared, okay? That just helps you know what to put exactly into the calculator, okay? Do the working on the side. It will help you out. That's what I did in my last exam, in my finals. So now I just need to carry out the test. So the probability that y is less than y, because it's a lower tail. And what is it? 164.6. That is my value I'm testing against. 164.6 is my test statistic, which is going to be equal to, and I put this in my calculator, which is 0.0347. So my calculator, I use the normal distribution. My upper limit is 164.6. My lower limit is negative 9999999, so on. My sigma is this thing here, 37 root 2 over 50. See, it's so much easier to put it that way. And mu is 166.5. So this is it to 4 decimal places. Make sure you say that you've rounded. And now I need to compare it to my significance level, which is 5%. The question said that is less than 5%. Therefore, it's less than the significance level. You can reject HO. Enough evidence to reject the null hypothesis. Therefore, enough evidence to support the belief, Mia's belief, that the heights of the female in the new country are less than 166.5 centimeters. So that is how you do a hypothesis test for a normal distribution. Does that make sense, guys? And make sure in the last bit to write down the full words. I've just not done it for time, but when you're doing the exam, write down all the words and make sure you are evaluating the correct thing. Awesome, I'm glad it's making sense. So that is the end of question 5. We've got one question left. In my opinion, it's kind of a fun question. I sound like a nerd saying that, but I'm a nerd. I'm doing maths papers, right? So, this question, awesome. I'm glad it helps the correct. Be for real. How is 7.4 squared? 1869. Going up here. Sorry. So, I'm not doing 7.4 squared. I'm doing 7.4 squared divided by 50 to get 1369 over 1250. And then I'm square rooting that to get sigma over square root of n and putting that in squared for that. All right. Yeah, we are all nerds. Awesome. We're gonna do a nice. In my opinion, this last question is a nice, fun question. So this is the previous paper was that obnoxious arithmetic sequence question, which you needed to like put in a lot of brain power. This is another similar type question, but this one is not so bad, and you're gonna see why. This is a beautiful end to this paper. So the discrete random variable x has this distribution. So this means x can take the values a, b, and c, and these are the probabilities of each of these values. So where a, b, and c are distinct integers, where a is less than b is less than c. What is this? Trust me, this is going to make sense. This is probability distributions. You need to know how to do these types of questions in case they throw a wild card at you. It's a nice question. So this is telling me that the c is bigger than b, which is bigger than a. And they're all different integers. And all probabilities are greater than 0. Question A, find the value of A, the value of B, the value of C. We're going to work this through. You only know one fact. Whenever you see this question, I need you to think of this. The sum of all probabilities is equal to 1. All right? So that means that log 36 of A plus log 36 of B plus log 36 of C is equal to 1, right? Because these are all my probabilities summed together. Exactly 007. They all add to 1. Now I can just use log laws because they love to use pure content in a applied paper. So if you're adding logs with the same base, you could just multiply them through. So you have log of 36 of ABC is equal to 1. Now you can see this actually becomes quite nice. So 36 to what power is ABC? So that just means ABC is equal to 36 to the power of 1, which is just 36. Awesome. I've got ABC's 36, and now I need to solve what A, B, and C are, and you can do a bit of guesswork, or you could kind of logic it through. So I need factor pairs of 36, and then I'm going to try and split up one of those factors into another, right? So I'm going to say 2 times 18. That's my go-to one, all right? So 2 is a prime factor. 18 can be split into 3 and 6. Oh, cool. I've already got 3 different numbers, which are all greater than 1, and they're all integers, and they all multiply to get 36. I can just stop there. Or I could continue going. If I just say I did 3 and 12, I need to verify that there's no other ways of doing this. So that is a prime. Then you have 6 and 2, and this goes into 3 and 2. Well, they're not distinct, and there's 4 of them. So, well, I've already got my answer here. Let's just roll with it, right? So the 3 numbers I have are 2, 3, and 6. Now I just need to assign them correctly, right? So A is smallest. So A is 2, B is 3, C is 6. Boom, 5 marks in the bag. Does this question make sense? Do you see why I said is not? Yeah, 6 can be split into 2 and 3. 2 and 3. But remember, you need 3 distinct integers. Well, these are 3 distinct integers, and that's all you have to do. You're not doing prime factor decomposition. This is just my way of doing it and laying it out neatly. So if you have 3 and 12, well, you need to split 12 and get 2 other distinct integers, right? 12 splits into 6 and 2. Oh, shoot, my bad. 3, 6, and 2 is already there as well. So you can see, ignore my waffle then. In other words, yeah, don't split 6 onwards. You've got 3 distinct integers. Roll with it, okay? Those are your 3 numbers. Sorry, my mind just went blank. So, yeah, 3, 6, 2. Make sure you assign them correctly here because A is the smallest and C is the biggest. And boom, 5 marks. Beautiful problem-solving questions. Both ways worked then. Yes, both ways did work. So, yeah, you could just use factor pairs. This is my way of doing it. Or you could guesswork, right? So what 3 numbers multiply to get 36, and then find 3 different numbers, and boom, done. Last question is, again, a bit of a weird one, where we got to understand the notation. That's the hardest part. The independent random variables, x1 and x2, each have the same distribution as x. So remember the previous paper we did, there was d1 and d2 have the same distribution? Well, I'm just going to put in my values over here. So this is 2, this is 3, and this is 6, okay? Find the probability that x1 is equal to x2. So let me say this in normal words. If x1 is equal to x2, these are just two other events with the same outcomes, A, B, and C, and the same probabilities. That's what they've said. So the way they're going to both be equal is either if we have x1 is A and x2 is A, or they're both B, or they're both C. Do you see how this works? Why it's not too bad once you understand the notation. So therefore, the probability that x1, one second saving, x1 equals x2 is A, the probability of A times by the probability of A, which is log 36 of A squared. So that's just log 36 of A squared. Or you could have this, so you plus that, log 36 of B squared plus log 36 of C squared. And if you plug in your values, well, A is just 2, B is 3, and C is 6. And you evaluate that, you get 0.0374 and so on. I would recommend writing these intermediate values out just in case you get the wrong answer at the end, but the examiner can see what you're doing. And then you add them and you get 0.3814 to 4 decimal places, and that's a wrap on the 2021 paper. Let's see any questions. I didn't understand this part. I am going to explain it again. So the question is telling you that you've got two other variables, x1 and x2. They love using that notation just to say that they're basically variants of this, but the distribution is the same. So if I just imagine that this is the distribution for x1, the values are 2, 3, and 6, and they've got the same probabilities. You have the exact same table for x2 as well. They want the probability that the value chosen for x1 is the same as the value chosen for x2. So if I go down here, they're both going to have the same value if they're both A. So if I choose A from both, or I choose B from both, or I choose C from both. So the probability that x1 is equal to x2 is, if I have A and A, well, what is that? That's log 36 of A times log 36 of A, which is just log 36 of A squared. A is 2, I knew that, plus the probability of B and B, which is log 36 of 3 squared, plus log 36 of 6 squared. If I add them, if I evaluate the squares, I get that, and if I add them, I get this probability at the end. Does that make sense, H? Hopefully that explanation worked. So yeah, you can get weird probability distribution questions. How comes you multiply them or square though? Because I got stuck and said they are the same. Okay, so I just kind of did it a shorthand way. So I said you want A and then A, right? So the probability you get 1A is log 36 of A, right? And then it's a successive event, right? So then you have another A. So you're multiplying by log 36 of A again. I just wrote that shorthand as log 36 of A squared, right? Because you're just having the same value multiplying it by itself is log 36 of A squared. And the reason you're multiplying it is because you've got one event followed by another. Successive events you have to multiply across. It's like a tree diagram, right? Where you multiply across the branches and then you add up the separate things on the other branches. The separate things you're adding here is BB and CC. So is it A equals A? Yeah, basically you want the x1 value. Here they're telling you you want the x1 value to be the same as the x2 value. So they'll be the same if you pick A and A for both, B and B for both, and C and C for both. I evaluate those probabilities. So yeah, it's exactly similar to a probability tree. And you just like, if this kind of helps, so you could have, I'm in rubber mode, A, B, and C, and then you could have A, B, C, A, B, C. This is x1, this is x2, and this is A, B, C. So I need them to be the same, right? So it would be A and A, so I multiply across the branches, right? So it's A and A, or B and B, that's also the same, or C and C. It's kind of like two green counters drawn, right? Or two of the same color. So here, it's two of the same letter, and you are just multiplying across the branches and adding the probabilities. Add probs across. Yeah, this diagram probably might help. Awesome, no worries. Imagine doing maths. I can't imagine it, I'm doing. But yeah, so yeah, I hope that explanation with this tree diagram visualization helps you understand how to do these weird sorts of questions. It is in the probability distributions chapter, but it's not really its own subsection. But yeah, this one exactly was not that bad, which is why I enjoyed this question. It's a nice ending to it. But other questions like that weird arithmetic sequence question takes a bit of thinking, but is not impossible. So before I wrap up, is there any questions you guys have for me? I'm going to do the mechanics live, same time tomorrow, 6 to 8. So I'm going to do mechanics, paper 2020 and 2021. I personally love mechanics, so I'm going to enjoy that one a bit more probably. But yeah, and then Wednesday, we'll do stats and mechanics 2022. The hardest stats question I did was the 2023 one, and it was the probability distribution. Yeah, I think what was that was the Tissam one, right? Where Tissam was throwing coins into a cup or something. Oh man, I hated that question. So hopefully you guys don't get as obnoxious a question as that. Last year, the stats paper wasn't too hard. I think question one from last year's paper was the hardest question in my opinion. Like question one had me stumped. I did the rest of the paper, came back to question one at the very end. But yeah, 2023 paper, I don't know what they were doing with 2023 when they were making the last two questions, the second last and the last question was kind of weird with that frequency polygon and all that question. But yeah, I just want to ask, how did you guys find your paper two? Because I've heard a lot of mixed things, but overarching, I've heard that it was bad. But how did you guys find it? Uh, like, what are your thoughts on that? It was good, nice, glad it went well. Awesome. Better than paper one. Okay, that's good to hear. Way better. So yeah, gonna get the A star with the last paper. We want to make sure we're good with those stats and mechanics. Um, I love paper two, but I do, yeah, further maths. I did further maths too, and I was looking at paper two, and I saw like some of the questions, if you did further maths, it's the problem solving bit I think that helps with that. All the big questions were fine. Okay, that's good. Awesome. So I'm glad you guys found that good. I saw the last question is just a bit weird. Some of the questions are just weird, but if you take a breather, you can figure them out. Vectors question, I had no clue. Yeah, there was a. Remember when I was doing the live before, part B vectors, when I was doing the live, people were saying that vectors came up. And I was like, I'm just going to do it again just in case because you never know. Kind of glad I did, but it wasn't the question we went through. But yeah, we had differential equations. Your life saved me. Awesome. I'm so glad that it helped. Honestly, that's exactly what I want to hear. That's why I do these, right? So yeah, I had a feeling differential equations and rates of change would come up. But yeah, first few questions not too bad. I think there was one weird trick question where it was like how many values or something it had and what was the value of k. That one you had to do a bit of thinking of trig functions in a weird way. They also do those type of questions, vector questions, to be honest, with lambda or mu. Yeah, lambda or mu. That is the thing. I personally hate geometric problems in vectors. I don't know if it's just me with lambda and mu. But yeah. What should I revise? I barely know any stats. Okay, my way. So I left my stats and mechanics revision mostly to the last few days, but I did the harder topics before the exam started. My opinion, do the harder, longer ones first, which tend to be from year two. From statistics, the hardest topic would be normal distribution. Start off with that. Make sure you're happy with all normal distribution, and then just work your way. Do the other two chapters in year two stats, because they're just three chapters from memory, right? In year two statistics do all of those. You can do those in not too long at all, except spend time in chapter 3. Then go into year 1 stats and go, again, hardest to easiest. So start off with hypothesis testing. If you don't know how to do that, then start off with binomial. So if you don't know how to do the hard thing, go for the basic thing and then work your way towards that. And same with mechanics. Do the harder stuff, then go down to the easier stuff. Or if you struggle with the harder stuff, start with the easy and incrementally work your way. Because year two is just kind of a build on from year one plus a few new topics. For mechanics, is it just like a pattern with, yeah, I'll be completely honest. Mechanics is more predictable than stats. That's like, even my teachers used to say that. It is more or less the similar style for each paper. Like, you're gonna almost guaranteed, have a projectiles question, which will be a big one. Personally, projectiles is my favorite chapter. I love projectiles. So I don't know how you guys feel about it. But yeah, projectiles, I've seen it come up every year because it's its own chapter, right? It's its own individual thing. You have definitely a forces problem where you've got either moments or resolving forces or pulleys or slopes or friction, something to do with that or the other. Incline, yup, incline can guarantee to come up because I want to assess that. And friction as well, almost guaranteed to come up. You need to understand how friction works for those weird one markers, you know, with the, if you increase the friction or change the slope angle or what happens to it with friction. Oh my goodness, please, please, please over projectiles. I will go, oh, with vectors. I haven't done, the questions don't have vectors, but I'll tell you how to do them. They're pretty much similar as without vectors, and I'll tell you why tomorrow. But yeah, and then you're guaranteed to have a variable acceleration. That's the video I posted like 10 minutes before this live. Variable acceleration. That's a year 12 content I posted, but it's most likely going to be year 13. So you're going to have to integrate or differentiate with vectors most likely, which again is not too bad. You're just doing two lots of the thing. Don't get confused. I don't like vectors or kinematics vectors. They're just weird. They are weird and they're messy, but they are not too bad. Like the questions cannot be overly random unless they decide to say, so God knows what Excel can make nowadays. But yeah, they are guaranteed to come up because that's assessing your calculus with mechanics. I'm going to tell you, for the stats and mechanics, I'm like trying to predict or guess what could come up because they were very weird in terms of not including certain topics in paper 2. They could include parametrics. I'm saying this with caution. They could include parametric motion in your mechanics paper because the last section, modeling with parametrics, did do similar questions, but may or may not come up, like integrating or differentiating parametrics. You need to be good at like all of your pure content for your applied, just in case any of them come up. Because here you can see you need to know your log laws and prime factor decomposition there to do this question. What else do I think could come up? I feel like you could get a binomial question if they're really weird, but it's very unlikely they'll give you a weird binomial. Yeah, no parametric in pure was crazy. So be on the lookout for parametrics. Who knows? They could put that, or they may not. This might just be the one year they don't give that question. But it's better to be safe than sorry. Just do a few of the parametrics. Parametric, not too bad. Just do one on X, one on Y, merge them together to get T, and do that. Last question. What's the position vector formula? Yeah, so position vector formula, you need to remember. So if we're doing like, it's like S equals UT plus half AT squared one, right? Or any other. So R, you need to have the initial, this is the initial position. And we need this as an offset. Plus half AT squared. I put these under the vectors. So this is the, sorry, plus UT, my bad, I forgot that 1 second. Plus UT plus half AT squared. You need to have this initial position vector to add to your final. This is your final position, right? Because if you don't have this, you're assuming it just starts at the origin, right? But if it started here and moved here, you need to have this little offset by adding this here. That's how it works. No parametric, yeah. Last question. I'm pretty sure there was one. What topics do you think will come up this year? Honestly, you can never know, but probably you're going to definitely have things like normal distribution comes up every year. Projectiles, from what I've seen, comes up every year. You're going to have a weird applied forces question, which is like moments or resolving forces, slopes, or hinges and rods, or those sorts of questions. That is going to come up for sure. Slopes, friction, and variable acceleration. These are going to come up for mechanics. And stats, normal distribution, probability distributions, binomial, hypothesis testing, linear regression stuff, pretty much everything. But yeah, one or the other. Probably another coordinate. Oh, maybe no set notation. Who knows if you need to... Yeah, you guys have had set notation in paper 1 and paper 2, which is good that I went through that on the live before paper 2. But no set notation. That can come up with probabilities, right? All right, awesome. So I'm going to wrap up there. Hopefully this live was useful for statistics. Hopefully it eased your nerves for stats. Tomorrow I'm going to be doing mechanics 6 to 8 same time, so follow if you want for that. I also appreciate the follows, the likes. I know exam season is coming to an end, but I'm hoping you guys will still follow me, trying to grow my channel and all. But yeah, hopefully that was useful. Thank you everyone for joining. Best of luck with your revision, and feel free to let me know if you have any questions or how your exams were and stuff like that. So yeah, tomorrow will be mechanics. Wednesday will be stats and mechanics. You can check my pin post to see when they are. And I'm going to be posting one stats and one mechanics video each day, like well tomorrow and Wednesday, to the build up of the exam of like key topics that I think for sure may definitely come up and things you need to know. And I'm doing, yeah, trying to make them as fun as possible with a little theme on each day related, little storyline. All right. Does anyone have any questions, or we all good to wrap up now? What software do you use for this laptop to do math on? So this is just a PDF. You can see I've just saved them in my PDF file, and it's not on my laptop. I'm kind of screen sharing from my iPad here, see? So I'm just doing a screen mirror from my iPad to show it on the laptop. But yeah, hopefully, yeah, that's what I do. So I just use PDF to do it. All right, cool. I'm gonna wrap it up there. Thank you everyone for joining. Thanks for all the support. Best of luck with your revision. Bye bye.